Yes, welcome back. So in the previous topics, we were discussing about the longitudinal stress and then circumstantial stress. Along with that, we have derived the equations in order to solve the numericals. So now we're going to discuss, we're going to solve the numericals based on this. What we have derived the equations based on the conditions. We're going to solve the numericals. Yes, first we're going to see what is the data they've given. So a boiler cell is to be made of 20 thick thick plates having a limiting tensile stress of 125 Newton mm square. If the efficiencies of longitudinal and circumferential joints are 80% and 30% respectively, to determine they have given there are two conditions. One is the maximum permissible diameter of a cell for an internal pressure of 2.5 Newton per mm square, and next one, the second condition what they have given is as a permissible intensity of an internal pressure when the cell diameter is 1.6 meter. See what they have given in the question or in the data is a boiler shell. A shell is made up of a 20 thick plates and then having a tensile load, that is the tensile stress is acting of 125 Newton per mm square. If they given the efficiencies of a longitudinal and a circumferential joints are 80% and 30% respectively, so we need to determine based on this. First condition is the maximum permissible diameter of a cell for an internal pressure. See, they have given we need to find out the diameter for to withstand the internal pressure of 2.5 Newton per mm square. For that, what would be the suitable diameter if based on the above conditions what they have mentioned. And in the second condition what they have given is a permissible intensity of internal pressure when the cell diameter is 1.6 meter. And the second thing is what would be the suitable pressure to match for the diameter of 1.6 meter, or that is what we call it as an, if you convert to millimeter, 1600 diameter shell, what would be the or how much pressure it can able to withstand, that we need to find out based on the given conditions. So now first we are going to see about the data. So what they given data is nothing but thickness they given of 20 and they given a tensile stress of sigma 125 Newton per mm square, and they're given as an efficiencies for the longitudinal and then a circumferential joints are, that is either we call it as NL and NC, that is 80% and 30%. Now by using this data we'll find out the solution for this. Yes, so now first we're going to find out the solution. So first is nothing but where you can able to see the permissible diameter of P. The diameter of the P what they given is P, they given a pressure for 2.5 Newton per no, 2.5 Newton per mm square, and the longitudinal for longitudinal joint the permissible stress, the formula is sigma will be equal to PD by 2 into efficiency of L, and we know the sigma is nothing but a tensile stress already given of 125 Newton per mm square, and they given as a pressure of 2.5 Newton square, and we need to find out the suitable diameter for this D, and the formula divided by 2 into thickness. The thickness is nothing but they are given a thickness plates as in a 20 along with that they are given as an longitudinal efficiencies for longitudinal joints for an efficiency is 80%. So that is what we have taken as a point 8. Now by substituting, by taking the d outside and cross multiplying, that is 1.5 into 2 into 20 into 0.8 divided by 2.5. If I make that substitution, so we are going to get as an diameter of the shell d is 1600 So this diameter of the d is when we are substituted for a permissible diameter for a longitudinal joint. Similarly, they are given for the both the, we can able to see in the problem they are given for longitudinal joints and then circumferential joints. So we need to find out for the both the diameter, then we need to find out the which is the minimum value or which is a suitable value. Now we got a diameter of a shell. For the permissible diameter, if the pressure is 2.5 Newton per mm square for a longitudinal joint. Now similarly we need to find out for a circumferential joint for permissible stress, sigma will be equal to PD by 2T into efficiency of C. C is nothing but a circumferential joint. Again same the P, that is what we have in a sigma tensile stress is 125 Newton and the pressure is 2.5 Newton per mm square, and again the diameter is unknown divided by 2 into 20 is nothing but a thickness, and 0.3 is nothing but an efficiency of circumferential joint. Again when by taking the d outside 125 into 2 2 into 20 into 0.3, if I substitute and divided by this 120 2.5, then the diameter of the shell what we got is d is nothing but an 1200 mm. See, now we have identified the permissible diameter for a longitudinal joint, and we have identified the permissible diameter for a circumferential joint also based on the given stress. Now what we got as the diameter for a shell is for a longitudinal joint is 1600 mm. Diameter of the shell for a permissible circumferential joint we got as in 1200 mm. So in this we will going to always we going to select the minimum value as in a permissible diameter. So the minimum value of the permissible diameter is now 1200 mm. Now with the diameter we are going to select is 1200 mm. Yes, that is what. And the second condition what they have mentioned is permissible internal pressure D is they have given a diameter. Here we need to find out the pressure. Same first case was similarly how we have find out at the first case. Similarly here also we are going to find out for the instead of diameter here we are going to find out for the pressure now. So for the diameter they given as an 1.6 meter, so we have converted to the 1600 mm, that is millimeter. So for a longitudinal joint permissible stress sigma will be equal to PD by 2T into efficiency of L. Again the sigma will be equal to 125. P is we need to find out the pressure here, and the diameter what we have is 1600 divided by 2 into T. T is nothing but a thickness, and efficiency of L is nothing but a 0.8, that is 80%. Now again by taking the P outside, so cross multiplying, that is 125 into 2 into 20 into 0.8 divided by 1600. So I am going to get an internal pressure of 2.5 Newton per mm square. So this is the what the internal pressure what we got is for a longitudinal joint based on the given diameter. The diameter is given, so for the longitudinal joint of 80% efficiency of the 80%, the pressure is 2.5 Newton per mm square. Now again similarly we need to find out for the circumferential joints for the permissible stress, that is sigma will be equal to PD by 2 into T into efficiency of C. Again the sigma is 125 Newton. Again we need to find out the pressure, and we have a diameter of the 1600, and again 2 into thickness is 20, and 0.3. The 0.3 is nothing but an 30% they have given for a circumferential joint. So we are substituting or we are converting that point to the values. Now if I am going to substitute that along with that internal pressure P, so now we got an internal pressure of, by substituting, that is taking P outside, so we have cross multiplied along with the 1125 into 2 into 20 into 0.3 divided by 1600. So now what we going to, what the value we got is when we substituted for an internal pressure P, we got as a 1.875 Newton per mm square. So the internal pressure P will be equal to 1.875 Newton per mm square. So this pressure is for an based on the circumferential joint, and this is the pressure what we got as in 2.5 is we got as based on the longitudinal joint. Now based on this we going to identify or we going to select the minimum value. So now the minimum value is in this along with the longitudinal joint and a circumferential joint when we substituted by using those equations. So the minimum value is 1.875 Newton per mm square. So now this will be the suitable pressure for the diameter of 1600 mm shell diameter for a cylinder shell. So this would be the suitable pressure. So based on these two conditions, so we have satisfied the, or we have identified the solution for the condition. One is for to find out the diameter, and one is for to find out the pressure for a boiler shell with a it is made up of an 20 mm thickness plates to withstand the stress of 125 tensile stress of 125 kN per mm square, and the diameter we got for a first condition. And second condition, see always we are going to select the minimum diameter and then a minimum pressure where it can able to resist the internal pressure, and the smooth functioning of a cylindrical shell or a vessel can able to be considered by using by selecting the minimum, by selecting the minimum values. So this is how we can able to, or this is how the equations we are going to use in order to find the solution for the given data. Thank you.